Hi, I'm Rich with InsideHPC, and we're here at SC12 in Salt Lake City. We're here at the Intel booth, and we're here to talk today about the Intel Xeon Phi. So I'm going to start with you, James. James Reinders from Intel. What happened this week? You know, we had an announcement of the Intel Xeon Phi brand about 6 months ago, but what happened this week?
Well, that's right. About 6 months ago, we gave it a name. What we announced this week is that we've been shipping them, and that we gave details like configurations, like they run up to 61 cores, how much memory they have, so forth, and give people something to order. I think maybe one of the things that surprised people a lot was how much support we have in tools already, and how many of these devices we've actually shipped. We appeared 7 different places on the top 500. Not bad for a debut.
Terrific. So, you know, we're here at the Intel booth at the Altair stand. So I want to ask you, Paresh, you work with these engineers, the people in Detroit, the people that use computational tools to be more efficient and build better cars, things like this. So from your perspective, what does Xeon Phi bring to the table there? And especially in the context of Altair, a company that manages, these big workloads.
Yeah, great question, Rich. This simulation software, such as RADIOSS, explicit and implicit, are very heavily used in automotive and aerospace industry to do the simulations. Doing simulation eliminates need to do a real-world crash of a real car, right? So that leads to a lot of productivity improvement. And there is never enough computation power to do these simulations in a kind of a consistent, fast way so that engineers get the feedback. And tools like RADIOSS and batch queuing systems like PBS Professional allow you to efficiently use the resources, and also applications can be speeded up using Xeon Phi core processor. So it's a great combination of the hardware and software that allows have a higher impact.
Well, I want to double click on that, Paresh, because, I heard a lot about RADIOSS and specifically on Xeon Phi. Is that what we're looking at here, and what's the advantages you're seeing?
Yeah, we are actually looking at 2 software products from Altair. One of them is RADIOSS. This is the explicit one. This is RADIOSS implicit, and both of these have a different capability. This one is used for impact stresses. So as you can see, this car is rushing into the wall and impacting, and you can see the color changes due to the stresses. And this one is a bought hull from America's Cup, and this is an implicit code, so something is banging here, and as a result the displacements are being displayed. So this is a great engineering problem that is being solved. But the great thing about this is now Xeon Phi is able to make these things run up to 2.5x faster to do this simulation. And we are actually using 2 different programming modes to do this on Xeon Phi.
Well, terrific. Well, James, I want to wrap up with you and ask about, Xeon Phi. It seems to me to be showing the flexibility of the thing, and it doesn't seem like it's a lot of work to get there. Is that a fair statement?
Yeah, absolutely. In fact, I think the work that was done here really highlights the power of the programming model choices that we bring with the Intel Xeon Phi coprocessors. One of these models is the explicit model. The impact model is actually running native on the Xeon Phi coprocessor, meaning that it isn't doing offload from the processor. It's just using it as an SMP on a chip, which is how it looks programming-wise. The other model is running on the Xeon and is doing offload, which is a model that people that have used other accelerators, other devices may be familiar with. And that model turned out to fit their software well. This is really a unique thing about Intel Xeon Phi, is this flexibility. They just matched the model that fit their software the best, and it did it. And because it's got that x86 goodness and the SMP on a chip sort of characteristic, we've really just left it as a parallel programming problem, not a big porting effort. And so millions of lines of code came across that would have just been too expensive to port to other devices.